It's a real competition co-hosted by the Pokémon. When you submit your AI agent, it automatically...
Oh, there are proper win/loss results.
The engine has a feature that records the...
On social media, posts about a Pokémon card AI tournament are everywhere. Having AI battle with Pokémon cards, what does that even mean?
It's a real competition co-hosted by the Pokémon Company and Google's Kaggle.
The official Pokémon Company and Google?
The total prize pool is over $300,000. That's a serious chunk of money.
That's huge.
What you build is an AI agent that plays Pokémon card battles. The simulator handles all the rules and game flow, so all you need to create is a deck and the logic for how to play on the board.
So you can focus purely on the card game battles. That sounds fun. Sharina wants to try it too.
Great, let's enter this competition together. The agent itself is basically just written in Python, and you can get AI to help, so it should be easy to write. Of course, if you're serious about winning, it gets difficult.
If it's just about getting a submission in, Sharina can probably manage that.
This time, let's walk through the whole process from registration to making your first submission. The competition is called the Pokémon Card Game AI Battle Challenge. It's organized by the Pokémon Company, partnering with Kaggle. I'll explain Kaggle later. Overall, there are 2 stages, Round 1 and Round 2. Round 1 is split into 2 divisions. The first is the Simulation Division. Deadline is August 17. When you submit your AI agent, it automatically battles other participants' AI on Kaggle.
So you're up against other participants' AI. You're competing against people from all over the world.
Wins and losses determine your rating, and that number decides your ranking. You can submit up to 5 times a day, so you can keep improving and resubmitting. However, this division has no prize money, only medals. The second is the Strategy Division. Deadline is September 13. This one isn't about the AI itself. You submit a strategy report.
What do you write in the strategy report?
It's a document explaining why you built your AI with that particular strategy, what hypotheses you formed and tested, why you chose that deck composition. You summarize that kind of thinking in under 2,000 words. Judges evaluate it, and the top 8 teams are selected. Even if your battle ranking is low, you can still make the top if your analysis is deep enough. To enter the Strategy Division, participating in the Simulation Division is a prerequisite. Each of those top 8 teams receives $30,000 in prize money.
So that's everything up through Round 1.
Right? And those 8 teams advance to Round 2. The Round 2 prizes are $50,000 for first place and $30,000 for second. Combined with the $30,000 from Round 1, the winning team takes home $80,000. Also, everyone who advances gets $3,000 in Google Cloud credits. However, the schedule and battle format haven't been announced yet. It still says coming soon.
I wonder if in the end they'll have humans battle with the decks they built.
There are over 1,000 cards available. You choose 60 from them to build your own deck.
I thought the AI would build the deck too, but you do that part yourself.
That part is the same as a regular card game tournament.
So what is Kaggle in the first place?
It's a competition site for data analysis and machine learning, run by Google. Companies and research institutions post data and prize money, and participants from around the world compete on AI accuracy.
Sounds like only super smart people would use it, and that the user base would be small.
Actually, there are millions of registered users. It's one of the world's largest data science communities.
What kinds of competitions are there?
The most famous beginner-friendly one is the Titanic survival prediction, figuring out who survived based on passenger data.
Oh, the one that always comes up in machine learning tutorials.
There are also serious prediction competitions, where companies post real-world data and prizes. And like this Pokémon card event, there are also simulation-style competitions where AI battle each other.
So it's not just predictions, there are battle format competitions too.
There have been game AI battle competitions for a while, like Connect X and Lux AI. Pokémon Card falls in that same category.
I see, so Pokemon card is the battle format type?
Another great feature is that you can run Python directly in the browser using Kaggle notebooks. There's a free GPU quota too, and the data lives in the cloud, so you can get started without setting up a local environment.
Not having to deal with environment setup lowers the barrier for a lot of people.
Plus, you can learn from public notebooks and discussions where others share their approaches. Performance is ranked on a leaderboard, and you can earn medals and titles like Grandmaster.
Sharina wants a cool title too.
This Pokemon card tournament is hosted on Kaggle, so you'll need to create an account first. You can create a Kaggle account with email or a Google account. Also, make sure to complete identity verification and phone number authentication beforehand. You'll run into trouble later if you don't.
What does identity verification involve?
The usual thing, taking a photo of your face. This is sometimes reviewed by an actual human, so don't take it shirtless or make a weird face, okay?
Nobody would take an ID photo shirtless. Come on.
Once that's done, open the Pokemon card tournament page, click Join Competition, and agree to the rules. If you haven't registered, you'll get blocked when you try to download the files you need later. Make sure to register early, don't forget.
Click, click, click. Done. Sharina made it that far.
Now that you've entered, let's get the competition files ready on your machine. You can download the files manually from the browser, but this time we'll use the Kaggle API.
Why bother with the API?
If you're having AI write code and run things, the API is way more convenient. You can download and submit with a single command.
You can even submit via command.
Yes, so setting up the API key early makes everything that follows much easier.
What exactly can you do with an API key?
Download competition data and submit your AI directly. You can also check your submission scores and the leaderboard from the command line. Dataset and notebook interactions, basically all of it can be automated.
I'm curious. Does this cost anything?
Creating an account and the basic tasks like downloading files or submitting via API are all free. No credit card required, so you don't have to worry about surprise charges.
So there's no scenario where you'd get charged?
It's not that there's never a cost. If you go beyond Kaggle's free compute quota and connect your own Google Cloud to run things, you'll pay for that. But that's Google Cloud billing, not a Kaggle subscription. For what we're doing, it'll stay within the free tier.
So for normal use, there's nothing to worry about.
There is rate limiting to prevent overuse, so just keep that in the back of your mind.
So how do you get the key?
Open API tokens under Settings and click Generate New Token. That generates your API key. The setup command is displayed right there, so copy and paste it into your terminal if you need it.
Just paste the command that appears and run it.
Right. Once the key is set up, you can download the full set of competition files with one command.
Thanks to setting up the key early, the AI could handle all the downloading automatically. That was really handy.
Let's go through the contents of the downloaded files one by one. First, there's the card data CSV. It comes in both English and Japanese versions. Each row has one move, with all the card info. For example, Scissor X has 270 HP, Steel type, weak to fire. Move energy costs and damage are all there.
All of a card's stats are laid out numerically.
Some cards also have an ability, a special power separate from attacks. For example, Sylveon has an ability that prevents it from taking damage from Pokémon X attacks.
Abilities are listed in the same column as moves.
Cards also have a category, classification. Categories include things like Ancient, Future, Terrestrial, or a trainer's specific Pokémon.
Categories have their own dedicated column too.
All of this information is in the CSV. That's your source for making decisions in your logic.
So you read the CSV directly to use it?
Actually, no, from code, you get the same data through the engine's API. The CSV is for humans to reference and verify. The other item is the card list PDF. In addition to the card ID to name mapping, it includes a card image for each one. Even without reading it programmatically, you can look up which ID corresponds to which card, with a picture.
But what are the card IDs actually used for?
You'll use them later when building your deck. That's where you look up the ID for the card you want. The main thing is the folder called Sample Submission. It's the template for your submission. It has 3 items: deck CSV, main pie, and the CG folder. Deck CSV is the deck definition. Card IDs listed in the order described earlier. It's just card IDs listed row by row, 60 in total. Repeat an ID to include multiple copies of that card.
You look up the IDs in the PDF from earlier, then list them here.
Main pie is the agent itself. This is where you write the actual logic. It contains just 2 things: a function to read the deck, and a function called agent.
That agent function is the brain of the battle.
Exactly. How you think through the logic here is one of the biggest factors in this competition. We'll look at how to write it in a later section. The last item is the CG folder, the game engine kit provided by the organizers. Inside are Python files and a compiled binary. The battle rules and flow are all handled by this.
You don't need to touch it, just call it.
Right? All you prepare yourself is the deck and the contents of main pie. Now let's actually run the AI locally and try a battle.
It's a card game, so even if an AI is playing, it's more fun if you can watch the battle in action.
The engine that powers the battle is in the CG folder from the download. It contains 2 modules, CG API and CG Game.
API and game, so the responsibilities are split.
API has card data and board state information. Game has the functions that actually run the battle. First thing to do is verify that the engine loads correctly. Import all card data from CG API. It's a function that returns the full card list. Then run all card data and count how many results come back. If it returns 1,267 cards, all of them, the engine is working correctly.
So instead of jumping straight into a battle, you start by checking if the data loads at all.
Right. If that returns 0, nothing you do after will work. Once you confirm that works, write a script to run a full match from start to finish.
So you write the part that runs the battle yourself?
You use 2 functions from CG Game, Battle Start and Battle Select. They handle starting and progressing the battle. First, pass both players' decks to Battle Start to begin the match. What comes back is the current board state, OBS.
So OBS holds the full state of the board.
Check OBS, current, your index to see whose turn it is. Pass the board state to Agent OBS, for the current player's AI to decide what move to make. Pass the returned move to Battle Select, and the board advances 1 step, returning the next OBS. Then just repeat that call until OBS, current, result shows a result.
Start the match, ask the current player's AI, pass back the chosen move, loop that until the end.
The whole battle loop itself only takes a dozen or so lines. How you run this script depends on your environment. Windows and Linux users can read the binary for their platform directly, CG, DLL, or libc, so they can just run the script and battle right away.
Those 2 platforms need no extra setup.
This Mac is Apple Silicon, and there's no Mac OS binary distributed, so it takes a bit more work.
Oh, there's no Mac version. What do you do?
Run the Linux libc, so inside a Docker Linux/AMD64 container. It's like wrapping a Linux layer around things and running it inside that. Specifically, spin up a Python 3.11 Slim container with platform Linux/AMD64 specified. Mount the sample submission folder into it, and run the script inside the container. The Docker command gets long, so we wrap it in a script called run sh. Then you just call /run sh3 with the number of matches, and it runs however many you want.
That way, you don't have to type the long command every time.
By the way, if you don't need to run it locally, Kaggle Notebooks is the easiest option. That's already Linux, so you don't even need Docker. Okay, let's actually run 3 matches with the sample AI.
Oh, there are proper win/loss results.
Match 1 goes to player 0, match 2 to player 1, and match 3 back to player 0.
Even AI vs AI battles are genuinely fun to watch like this.
Seeing battles play out like this makes it clear what moves the AI is making. From there, you improve it and build a stronger player. That's the heart of what makes this competition fun. Now that we're this far, let's actually write the logic.
Are we going to use machine learning? That sounds complicated.
We're not jumping into machine learning yet. First, let's write it rule-based. It's just listing out priorities. In this situation, do this.
So it's basically a stack of simple if statements.
Exactly, for this trial run, let's go with these priorities. First, evolve if you can. Then attach energy. After that, play cards from your hand. Then attack with the strongest move. If there's nothing left to do, end the turn.
How do you determine what the strongest move is?
The engine's API returns a damage table for moves. You just reference that and compare. From the legal moves available, pick the one with the highest damage.
So it's the just hit hard, brute force approach.
That's fine to start. Getting something that works comes first. Do you know the game called Marshmallow Tower? The one where you build a tall tower with pasta and marshmallows. Adults tend to overplan the perfect design, then put the marshmallow on at the end and watch it collapse. Time's up. But kids just put the marshmallow on first, then fix it when it falls. More trial and error means a better tower.
So instead of overthinking, just run it and fix it. That's faster.
Same with AI. Start with simple rules, then improve from there. It's the shortcut. Also, these priorities only apply when choosing what to do on your main turn. That's for your main actions: evolving, attaching energy, choosing a move. For other smaller decisions, just go with safe, straightforward choices.
To really win, you'd need solid logic for those moments too.
Once the logic is written, let's try a battle against the sample AI.
I'm nervous, can we actually win?
Oh, we're winning more than losing against the random opponent.
Even a simple set of priorities makes this much of a difference. The battle video has come up several times. How are you watching that?
That's a replay of the battle being played back. The engine has a feature that records the full state of the battle as replay data.
So the board state for every single move is stored.
Right? Using the Visualize Data feature, the replay comes back as JSON. With that JSON, you can replay the entire battle as many times as you want.
The entire match from start to finish is all recorded.
The simplest version is a text replay. You can follow the turn-by-turn flow in text. Who drew a card, attached energy, used a move. All of it is shown in text. At the end, it shows something like game over. Player 0, my agent wins. Opponent has no Pokémon left. Even the reason for the result.
Being able to read it as a log is handy. Useful for debugging too.
That said, text alone makes it hard to visualize the board.
Yeah, I'd want to see it visually.
For that, there are viewers that display the board graphically and let you replay it in the browser. There's an official viewer and a community-made one.
There's an official one too.
Yes, it looks like it just came out from the official team yesterday. It's a web service by a company called Heroes. You pass your battle data to it, and it replays it cleanly on the site. You can also view submitted matches by selecting them from the playboard on the competition page.
It's reassuring that the official team provides it.
The other option is the community-made viewer you've seen here. It runs locally, and you can check replays immediately, even before submitting. You can step through frames or autoplay, and clicking a card shows the details. You can switch between English and Japanese too. Card images are cut out from the PDF in the distribution files. Neither is strictly better. It's just about where you're checking and how conveniently. For quick checks on your machine, the community-made one you're used to is probably the way to go. Both let you follow the board visually, so you can easily see how your AI is playing.
The tools are getting better and better.
All the attention this is getting means the community is super active. Expect changes like this to keep coming. Check the official community for the latest updates.
Somehow it really feels like playing actual Pokémon cards. This is fun.
We've been running it with the sample deck so far. Now let's build our own.
Oh nice, time for an original deck. But I only played Pokémon cards back in the red/green and ruby/sapphire era. I have no idea what the current meta is, so I'll just go with a Pokémon I like. I've always loved Scissor. I'll build a Scissor X deck.
Nice. First, let's look up the card IDs. You need IDs, not names, in deck CSV.
How do you look up the IDs?
There's a search script. Enter a name, and it shows the ID and effect.
Let's see. Scissor X is ID 84, and the pre-evolution Scyther is ID 916.
Right. Then you list those IDs in deck CSV. 60 cards total.
Okay, done. Is this right?
Let's run the validation tool to check the rules. It checks exactly 60 cards, no more than 4 of the same name, and at least 1 basic Pokémon.
Are there ban lists or restricted cards?
There's no individual ban list, but ACE spec cards. The powerful ones are limited to 1 per deck.
I want to see what happens if I break that rule.
Let's try it.
Adding 2 AC spec cards and running the validator. Oh, it threw an error. So it catches that. Good to catch it before submitting.
Fix it to 1 and run the validator again.
This time it passed.
Last step, run a test battle with the built deck to make sure it actually works.
The Scissor X deck. Let's go. Oh, the battle's running properly.
Your custom deck is ready. The deck and AI are ready. Now it's time to submit.
Is it just the AI code you submit?
No, you submit 3 things together as a single file called submission, tar.gz. Inside is main .py, the engine folder CG, and deck CSV.
You bundle the AI, deck, and engine all together.
There are 2 ways, but the easiest this time is sending via command line. Since we set up the API key earlier, we can send it directly from here. Just pass the tar.gz to the Kaggle command, and the submission is done. No need to open a browser. You can submit right from the terminal.
If you're having AI do everything, the command line is definitely easier.
The other option is browser only, using a Kaggle notebook. The official team has a beginner guide notebook. Copy it and swap out just 2 things.
If you're not comfortable with command line, that works too.
CG loads automatically, and you just save and run all, then submit. Also, you can only submit 5 times per day.
So you can't just try a bunch of different decks and logic over and over.
And after you submit, your copy plays a validation match against itself first.
So it doesn't go straight onto the leaderboard.
If the match can't complete, the submission gets flagged as an error and won't count toward ranking.
What if the logic has an infinite loop or crashes midway?
That also gets rejected. There's a time limit for thinking on each move. Even if you infinite loop, you lose when the time runs out. There's also an overall match time limit. Matches get cut off after around 10 minutes.
So it can't just run forever.
Same for logic that crashes. The side that crashes loses. Broken submissions don't sneak into the rankings, though a failed submission still counts as one of your 5 for the day.
Losing a submission slot to a failure hurts when you only have 5.
So it's worth doing thorough local testing before you submit.
We submitted. Now let's see if a battle is actually running.
Open the leaderboard tab and find your team.
There it is, a chronoitchannel.
By the way, this screenshot is from June 18, so things might look a bit different now. See the play icon in the agents column? Click that and
Game history, the battle log came up.
once you submit, you get automatically matched with other participants' AI, and battles run one after another.
The ones with a trophy are the 1 matches. Win, loss, win.
Click Open Visualizer and you can watch the replay for that match.
Is the number in the top left the score?
That's the rating. It goes up when you win and down when you lose.
The ranking is pretty low though.
Well, it's a sample deck with simple rule-based AI.
But it's properly getting matched and battling.
The goal this time was to submit and get a battle running. We achieved that.
My own AI is actually battling other players. This is so much fun. We made it all the way to our first submission. That was a lot of fun. I was bracing for something hard, but it felt surprisingly manageable.
Right? People tend to assume having AI battle is complicated, but the actual work is simple. The engine handles the rules, so you can focus on the strategy.
It seems approachable for both Pokémon card fans and AI beginners. But you still build the deck yourself, right?
Yes, deck building isn't left to the AI, so your Pokémon card construction skills get tested too.
It's not just about AI strength. Deck selection sense matters too.
Also, the fact that everything in this tournament, downloading and submitting, can be done entirely from the command line is a big deal. It fits really well with the modern workflow of having AI write code and running it from the command line.
Combine it with AI coding tools, and you can move really fast. We used simple rule-based logic this time, but aiming for the top would require something more sophisticated, right?
Yes, things like evaluating the board and making smarter choices. Look ahead with Search API or reinforcement learning. The official team has also put out sample notebooks on RL and MCTS, so you can use those as a starting point.
You don't have to jump straight to that level. You can level up step by step.
Before aiming for rankings, first submit once and see your AI battle replayed visually. Once you get there, it really becomes a lot more fun.
Even if it's not perfect, just getting it running sounds like a great first step.
And if you get hooked, there's nothing stopping you from going all in to aim for that prize. Oh, and if you're forming a team with someone, make sure to follow the official Kaggle team rules.
Sharina is going to build her own proper deck and give it a real shot too. If you enjoyed this video, subscribe and a like would really help us out.
See you next time.